Okay, here are the three ways to prove two triangles are similar. Now remember, when we're proving similarity, we're trying to show that their sides are in proportion and their angles are the same. Okay? So there's three ways that we can do this. And we're going to spend this lesson, 7.4, only on the first way, but I'm going to give you all three at once so you have them in one spot. First one is called AA Similarity. Yep.
So they're kind of similar.
No pun intended. But I got that, yeah. So angle similarity. So if you can show that two angles are the same and the sides are in proportion, that's the angle similarity. Then there is the side angle side similarity. Similarity theorem. And then there is the side similarity theorem. Okay? Yeah, these are all theorems, yeah.
What does that say? AA similar what?
AA similarity. So the angle similarity, the side angle side similarity theorem, and the side similarity theorem. We're going to focus this lesson on the first one here. We're going to focus this lesson on the angle similarity theorem. Okay? So these are the three ways that we can prove two triangles are similar. And notice I have the similar symbol there. Fair enough? Those are the three ways. Okay? I'm going to write down the angle similarity here. Angle similarity. It says this. No, it's not. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So this is the angle similarity. I'm going to give you a picture of it, still the same box here, an example. So let's say I've got this picture going on here. Okay, and I've got this picture going on here. And this is 74 degrees, and this is 71 degrees, and this is 74 degrees, and this is 71 degrees. Okay, clearly, well, not clearly, but I've drawn the pictures, hopefully, one's bigger than the other, so they're not congruent. They're not meant to be congruent. But to show that these two triangles are similar, all we have to show is that two angles are congruent. So I can see here that 74 and 74. That's one angle. The other angle that I have in each of them is a 71 and a 71. So by default then, right, the other one has to match the other one, right? How come? They all got to add to 180. So by default, whatever this one is left over, we can figure it out, has to match up with that one. But we don't need it. Angle similarity means you only need two of them, okay? So these two triangles are similar by the angle similarity because I have an angle there and I have an angle there. And that's enough to show that these are then similar. So if I give you this picture here, okay, the question is, do we have enough information to show that the smaller triangle and the bigger triangle are similar? Okay, well, first of all, do you see the two triangles here?
You see two parallel lines.
Okay, good. I see two parallel lines tied to. Let me show you the two triangles. There is this large triangle. This is the pink triangle.
There's a small triangle. Yes.
You guys cool with that one?
Side angle side.
And then do you see here's the smaller triangle in green?
And then we see a trapezoid.
Well, there is a trapezoid. Okay. Okay. The question is, though, whether or not do we have enough information by the angle similarity to show the green and the red are similar. Yeah, what do you think, Jelena? Yeah, so check this out. We have parallel lines, right? So parallel lines would automatically give us which two angles? I'll go blue here. Yeah, this one and this one. Why would that be true?
Corresponding.
Those are corresponding, right? Corresponding angles, if they're cut by parallel lines, then we've got a transversal, then those are congruent, right? So I have this angle here for the green one, and this angle here for the bigger one. Now, is there an angle that they share? Yeah, the top one, right? So this angle here, both triangles have that one, right? Both the green and the red have that triangle. So therefore, these are similar triangles by angle similarity. Okay, here's the picture that we've got. The question is, do we have enough information to show that these two triangles are similar? First thing I would suggest is if you can, draw colors around the triangles that we're talking about. So I'm talking about the big purple triangle here. This one here. Everybody see that one?
Are you saying is it similar to the...
And then I'm saying this other triangle here.
Well, they have there's one angle and then with the right
So do they have an angle that they share? Yeah, they have this angle that they share, right? So that's one angle that they share. You guys agree with that?
angle, another angle to the right.
And then they also know this one. This is right and this is right.
It is angle, angle.
So therefore, this is an angle similar. These triangles are similar by the angle similarity. Is that fair enough? Is that making sense?
This is gonna get crazy hard.
It can be confusing only because of the drawing.
It's gonna be like 18 triangles in one triangle.
Yeah, it's gonna.
You can actually see that happening.
Yeah.
On the homework. That's
Okay, here we go. It's 8 boxes long. So here's the picture that we have. This picture has got a lot of information in it, and this is a challenging example, so we're going to spend some time on this together. So does everyone have the figure drawn down?
Yeah.
Alright, so the first thing I'm going to ask you to do is
Does that say scale factor?
scale factor, yep. We want to figure out the scale factor from the small triangle to the big triangle, so we're going to identify which ones we're talking about. So here's the small triangle in blue. Okay, there's a small triangle. And then the bigger triangle, which is going to be in orange, is this bigger one here. Okay, do you guys see the two triangles I've got going on here?
Oh,
Okay,
we know that they have those two angles are corresponding angles because there's
yep, that's true. That's also true. But what I want to do here first is I want to figure out the scale factor, and then I want to figure out what A is, and then I want to figure out what B is. Those are the two things that I want to do. Okay?
3 to 5.
But you're right. Those two angles would be corresponding and congruent. Okay?
33 is half of A. I believe.
Yeah.
So
A
that's-
is
So A
No. That's the reason that's not true is because this length is not the same as that length. So that's not a median, right? That's not a median. Otherwise, you're on the right track, but unfortunately, that's not true. We don't know that, right?
got it. My bad.
That's okay. You're thinking. I like it. Okay. Oh, my orange went away. You guys cool with this?
Okay. So
Okay. So first thing, let's answer the first question, and that would be, what's the scale factor from the small to the big? Anybody see something that we can use?
-3.
This is the hard one to see.
30 to 20.
It's not 30 to 20.
20 to
What do you see? It's 30 to 50. I think you saw the same
Oh,
thing,
yeah,
right?
yeah.
Okay, why is it 30 to 50?
Because the big one is both of them.
Yeah, it's 30 to 50. So the scale factor, the small blue triangle is 30. The big triangle is 30 and 20, 50. So our scale factor is 30 to 50. If we simplify that, we get what?
3 to 5.
Okay, so now we have a small to big scale factor of 3 to 5. That's going to help us out, okay? So now we got to solve for A and we have to solve for B. All right, so let's solve for B first on the side. Here's what we know. We know that 3 to 5 is our scale factor from small to big. So that has to equal, what's the side of the small triangle that I know? 27, very good. Now, what's the total length of the big one on the side there?
27 plus
27 plus B. And that's the hardest part for students to see. So I want to make sure we point it out. The small one is 27. The total length is 27 plus B. Okay? So you have to visualize it. So now that we have this, how do we solve this?
So cross Jimmy Neutron.
Cross Jimmy Neutron, yeah, whatever that, I'm not sure what that means.
So 80
So 5 times 27 equals 3 times 27 plus B.
What?
I mean 20.
The ratio, the scale factor is small to big, 3 to 5. You got that? Okay, good. So 27 represents the small side, and then 27 plus B represents the big side. 3/5 is the scale factor over here.
That's from 30 to 50.
From 30 to 50, we simplified to get 3 to 5.
Why not use 20 and
20 and 50.
Solve the small one. That's what I'm trying to be fast.
Yeah, we want to go from small to big, right? So 30 to 50, 3/5. Is everyone okay with the 3/5?
Yes.
Okay. So we're gonna do the algebra here. What's 5 times 27? Help me out. What do you got?
135.
135. Very good. So 135 is now equal to 3 times 27 was 81. 81 plus a 3b. So therefore, minus 81, subtract or divide by 3. So what do you get for b? Very good. So therefore, b is now equal to 18.
Because
Okay, we also need to get a. All right, so what are we going to do for a?
no, it's not.
Nope, it's not 66. So here's what we know. We know small to big. We know in 3 to 5 ratio. What's the length of my small one?
30.
33. What's the length of my big one? A. This one's easier, right? So therefore, 3a has to be 5 times 33 is 100,
165.
165.
Where'd you get 160?
I am multiplying. I'm doing the means and extremes, right? So divide by 3. So therefore, a is a value of, I'm getting 55 out of this. Is that what you guys are getting?